Question 16 from the reading is also many steps to this question, and they have many questions associated with this, many follow-up questions that I'll all answer in this one module right here. So the first question, we'll get to that. What is the pH of a buffered solution containing 0.6 molar acetic acid and 0.4 molar sodium acetate at 25 degrees? And then the following questions are where it gets challenging. We add an acid to this buffer. So we have 90 milliliters of this buffered solution, and to this solution we add 10 milliliters of a 0.1 molar HCl to that buffered solution, right? What is the new pH of this? Is basically what they're looking for in all the questions that are associated with this. For the first question, it's not that hard. pH of this buffer, that's just a Henderson-Hasselbeck calculation, right? So the Henderson-Hasselbeck equation, pH equals the pKa plus the log of the concentration of my base over the concentration of my acid. So the pH of this solution would be the negative log of my Ka, 1.8 e to the negative 5, plus the log of the concentration of my base. The base is sodium acetate, so 0.4 divided by my acid, which is acetic acid, 0.6. The pH of this buffer, before doing anything, before adding anything to this solution, is approximately 4.57. And that makes sense because our concentration of our acid is a little bit greater than the concentration of our base, so we'd expect this to be a little bit more acidic than the normal pKa. The normal pKa was about 4.74, 4.75, so we're a little bit more acidic than that because we have a higher concentration of acid. To this, though, we add 10 milliliters of a 0.1 molar HCl solution. So again, now we have to take into account our concentration and our volume and find moles for everything in the reaction. So I'll start with the acetic acid and our acetate and our HCl. So again, I have a 0.6 molar solution. So 0.6 molar is 0.6 moles per liter. My acetate is 0.4 moles per liter, and my HCl is 0.1 moles per liter. Right, my volume, I have 0.09 liters of that solution. I take 90 milliliters of that buffer. So now I can move this from molarity, which is moles per liter, into moles, and I can figure out how much of each I have and how much is going to react. And I take 10 milliliters of the HCl solution, so that's 0.01 liters. Right, that cancels out. When I multiply through and I get a concentration of all of those, I'm going to get approximately 0.054 moles of acetic acid, 0.036 moles of my acetate, the conjugate base, and 0.001 moles of my HCl, so essentially proton. So now I need to figure out what that's going to react with, right? So I can draw my little diagram, right? My diagram is going to look something like this. And here's my acetic acid, my 0.054 acetic acid, my 0.036 acetate. To that, I add a proton, right? I add 0.01 moles of a proton. Where does that react? That's going to react with the conjugate base. That's going to protonate the conjugate base, right? I'm going to have this reaction. The conjugate base is going to react with the proton to form more acetic acid. So the concentration of acetic acid will go up. The concentration of acetate will go down as it gets protonated by the strong addition of that acid. So I'm going to add that concentration here. I'm going to add that concentration to my acetic acid because I'm going to make more. I'm going to subtract it from my acetate because I'm protonating that and I'm reacting with that, so that concentration goes down. So 0.035 of my acetate, 0.055 moles of my acetic acid. And more importantly, all of the hydronium reacts. The hydronium reacts completely. Now to answer the final question is, what's the final pH of this solution, right? The final pH of this solution, we need to take these moles, move them back into a concentration. So I have 0.055 moles of acetic acid and 0.036 moles of acetate. And now my new volume, right? Molarity is moles per liter. My new volume, I take 10 milliliters of the acid, add it to 90 milliliters of the buffer. My new volume is 0.1 liters, 100 milliliters. So my new concentration would be 0.55 molar acetic acid and 0.35 molar acetate. Right, this should be 0.35. 0.035. Now I can do the Henderson-Hasselback equation now that I've found the new concentration of my acid and its conjugate base. Right, so the Henderson-Hasselbeck equation, pH equals the pKa plus the log of my concentration of my base over the concentration of my acid. So the pH of this new solution after adding the strong acid to it would be the negative log of 1.8 e to the negative 5 plus the log of 0.35 over 0.55. The pH of this new solution comes out to be approximately 4.55. So as you can see, we got a small change in pH from our initial, right? Our initial buffer started right here. Our initial buffer started at 4.57 as a pH. I add a strong acid to that, so I'd expect the pH to go down. I'd expect the buffer to become more acidic. I add that strong acid, and my new pH, right, is 4.55. So that makes sense because I moved that in the right direction. But again, we had to do this calculation in the form of moles because our concentration is going to change as our volume changes. As we added those two solutions together, the 10 milliliters of the strong acid to the buffer, our volume changed, and because our volume changed, our concentration will change as well. So it was easier to do these calculations in moles, right? Figure out how much was going to react in terms of moles, and then move that back into concentration as we did down here.